Hello friends, now we'll learn about differentiation of logarithmic functions, right? So y equal to ln x differentiation is 1 over x, 1 over this, right? Okay. And if it is ln of a function, then the derivative would be 1 over this function, 1 over that, and then the derivative of fx. So 1 over fx and times the derivative of fx, right? Okay, so let's understand about part B, 11b. Y equal to ln 1 minus 3x. As we have learned, first we differentiate ln x graph, and ln derivative is 1 over that, right? So ln whatever is there, you differentiate this 1 over that. So I'm differentiating complete first. So 1 over 1 minus 3x, correct? And then I will differentiate the inner part, which is times 1 differentiation is 0 and minus 3x differentiation is minus 3. So which simplifies to negative 3 over 1 minus 3x, right? Okay. Great. So let's do some more questions ahead. Here it has been explained as ln kx from the property of ln can be distributed as addition ln k plus ln x, right? And ln k is a constant value, so its differentiation would be 0, and ln x differentiation would be. Some more properties have been discussed here. Ln of the product of numbers can be distributed in addition, ln a plus ln b, right? Product gets distributed in addition and division converts into subtraction. So ln a minus ln b, right? And this says when you have ln a to the power n, so power n goes behind ln and it becomes n of ln a. I'm not differentiating, I'm discussing the property of logarithm, right? So property of logarithm says the power of n will go behind and it becomes n ln a, right? So let's do one question here. Question number 12b we'll discuss. We have ln of this much, right? So instead of first start with differentiating, before that we'll try to break it up using the properties of ln, right? So ln properties says that ln of any fraction with numerator and denominator, you can break it as the numerator will go positive, so it is ln x square, and the denominator values will go negative, so minus ln of x plus 2, and this is again the second part minus x minus 3, right? So ln of numerator minus ln of all the parts of different denominator, right? So this is, we have simplified. Now we'll differentiate this, okay? But before that, the power 2, again a new property, will go back, will become 2 ln x, right? And now we'll differentiate. So I'm differentiating 2 is 2, and ln x differentiation we have learnt is 1 over x. So it is 1 over x minus ln of this much, right? Ln of x plus 2 will be first x plus 2. X plus 2 goes in denominator, right? 1 over x plus 2. And then Differentiation of x plus 2 will be what? X would be 1 plus 2 would be 0, right? And then minus ln of x minus 3. So it will be 1 over x minus 3, and under chain rule x differentiation is 1 minus 3 differentiation is 0. So it better written as 2 times 1 over x, which is 2 over x, negative, this is only 1, so 1 over x plus 2, and this is also 1, so negative 1 over x minus 2. So this is my final answer of the differentiation, right? Great. We'll do one question, let's say number 2e. 2e is this. So before we start differentiating, first I will use the differentiating rules, right? Please understand, right? It is the complete power of this thing, correct? So here we will use the power rule first, correct? I'm differentiating now. So power 3 may be behind, and ln of 2x plus 1 differentiation is whole square, right? Power 3 goes behind and the power reduces by 1 unit. We have learned from the very beginning. Because this is complete to the power 3, right? So we differentiated this. And then we'll differentiate the ln of 2x plus 1. Ln of 2x plus 1 is 1 over 2x plus 1. Correct? So I differentiate of 1. And then I will differentiate the inside part, which is 2x plus 1. And 2x plus 1 derivative is 2 plus 0. Because 2x differentiation is 2, right? So we have 3 steps. In the first step, we used the power rule where we brought 3 behind and then the power reduced by 1 unit. In the second step, I used the differentiation of ln, which is 1 over 2x plus 1. And in third step, I differentiated the inside value of ln, only 2x plus 1, right? So simplifying this, will get 2 plus 0, which is 2, and times 3 will give you 6. And this is ln of 2x plus another bracket and then whole square and all over 2x plus 1. Okay. Now here I want to discuss you one more question related to E only. If we have a question like this, if we have ln of 2x plus 1 whole cube, there is a small difference. In this question, when I put 2x plus 1 whole cube, the cube is only on 2x plus 1 and not on complete ln, right? So this can be further written as in a simplified form before differentiating. 3 goes behind. Property of log, right? I'm not differentiating right now. So ln 2x plus 1. So this is, I use the property of log. Property says the power inside ln goes just behind, right? Okay, now I will differentiate this. How? 3 is constant, so 3 stays as it is. And ln of 2x plus 1 differentiation is 1 over 2x plus 1. Differentiation is 2x differentiation is 2 plus 1 differentiation is 0. So this basically is 6 over 2x plus 1. So please understand, guys, that this, right? It is very important. Good. Let's do question number 3h. So we have ln of the product, and the product is x times that. We know that the product of the ln of the product breaks into addition. So it will get ln x plus ln of x square. I simplified it using the property of ln. Now I will differentiate it. So ln x differentiation is what? 1 over x plus this part differentiation is 1 over x square plus and times the differentiation of inner part x square plus 1 will be 2x plus 0, right? So simplifying will get it 1 over x plus x square plus 1. That is my simplified form, right? Okay, let's move on. Let's see. We'll do question number 13a. X times sin x. We have to differentiate this, and we know that this is a product rule. So I am supposing x and v as, so u dash equal to x derivative is 1 and v dash equal to sin x derivative is x. So I'm using the property u times v dash plus u dash times v, which is x times cos x plus u dash is 1 times sin x. So this is nothing but x cos x plus. Good. Okay, this is important. Now we'll learn how to differentiate. It is important because now it is getting complicated. It is 4 tan square 3x. Okay, my first step is, I'm just writing the first step. You use the power rule on tan 3x. It is nothing but tan 3x whole square basically, right? This is the first step you will differentiate. Second differentiation would be you will do tan 3x, right? And the third differentiation would be for 3x. So we'll do this one by one. Okay, 4 is constant. I'm writing it here, solving it, part B. 4 is constant. Now tan 3x whole square differentiation is what? I'm using the power rule. So 2 will come behind and tan 3x power 1. Power reduces by 1, right? Times. Now the second chain rule we are using here, right? This step 3 is actually chain rule, right? Tan 3x differentiation is, just now we have learned tan derivative is 1 over cos square. So it is 1 over cos square 3x. Okay, and the third step will differentiate 3x, and 3x differentiation is 3. So eventually my simplified answer is 4 times 2 times 3, which is 24 tan 3x over. Here guys, I need to tell you that tan square x is same as writing tan x whole square. Okay, whole square does not mean tan square x square, correct? Square will not be x, or it is also not equal to tan of x square, correct? Please understand this difference. Tan square x is same as tan x whole square. Okay, So good. Let's move on. Let's do question number 2C. It is again a product rule, u times x. So u dash equal to what? E to the power x, differentiation is e to the power, and v dash is cos x, differentiation is minus sin x. So I'm using the form u v to the power x, and v dash is times minus sin x plus u dash, which is e to the power x, times v, which is cos x. So we'll simplify it nicely. E to the power x taken common, cos x. Right? Okay. Let's try question number 3L. We have to differentiate 8 over tan cube x over 2. You know, better written as, I will write it like this. It's nice if you write it like this. This is 8 and I will write as tan x over 2 whole to the power minus 3, right? So it is 8 is constant and we will use one by one. First step is power rule. Second step is differentiation of tan, and third step is differentiation of x over 2. So I'm using that. 8 is constant. Power rule is minus 3 goes behind, and tan x over 2 power reduces by 1, so it is minus 4. That is the first step of differentiating the tan x by 2, right? So tan x by 2 differentiation is 1 over cos square x over 2, right? This is the second step. Third step is differentiating x over 2, and x over 2 differentiating is 1 over 2 is constant and x differentiation is 1, right? No issue. So we'll simplify with the constants. 8 times minus 3 times 1 over 2 will give you minus 12, right? Minus 12 over, I will bring tan x over 2 down, so I will better write as tan to the power 4x over 2 cos square x over 2, right? Now this can be further simplified as, we know that, I'm sure you must be knowing that, cos, correct? So this will bring cos, so negative 12 over sine to the power 4 x over 2 over cos to the power 4 x over 2. Good. Correct. Times cos square x over 2. And so 2 cos and 2 cos will be cancelled, right? So it actually becomes, I'm writing here, negative 12 over sine to the power 4 x over 2 cos square x over 2, right? Which further simplifies to, this cos square in denominator will come up in numerator, right? This is the main fraction, right? So it is negative 12 cos square x over 2 divided by sine to the power 4 x over 2, and that is my most simplified answer, right? Hope it is clear. So thank you for today. Goodbye.